We want to also look at minor segment and major segment of a circle. All right, let us look at our circle here. Now, this line we see here, that is line AB. In circle, we call it chord. Now, the chord is not passing through the center. It's passing at the down part of the center. All right, and the chord don't divide the circle into two equal parts. So we need to know that. So if this line is a chord, all right, the space beneath the chord here is called minor segment. And to be precise, we can be asked to find the area of this portion. So this is what we call, this portion we see here is what we call area of what? Minor segment. And how can we find the area of this portion? This is what we can do. First of all, if this is the center of the circle, all right, and we take one radius here, we take another one here, and this is the center, all right, then it means that the whole thing we see here, all right, become a sector. So if we have been asked to find the area of this shaded portion, first of all, we need to find the area of the whole sector. Then we find the area of the triangle that we can see here, all right, then we subtract the triangle from the area of the whole sector. And that will give us the area of this portion. All right, so let us look at it. Now, when we say area of minor segment, we say the formula is what? The area of the sector. And the area of the sector, all right, is given as what? Our angle here divided by what? 360 multiplying pi r squared. So this is the formula that we can use to find the area of the whole sector. Now, minus the area of the triangle that we can see, and this triangle is an isosceles triangle, all right, because from here to here is the same as from here to here. So minus the area of this triangle, which we can use half r squared sine theta, all right. So this is also a formula we can use to find area of a triangle, all right. I think we can use half base times height, but here this will be a simple formula that we can use. Now, the angle here is the angle that is formed here, all right? So let me put alpha here. And the angle here is the angle that is formed within the what? The triangle, as you can see. All right. Now, we can also be asked to find the area of the major segment, which means this whole portion. And if you look at this major segment, it's two things combined. We have the area of the major sector, and we have the triangle there. So we can say that area of major segment will be equal to, all right, the area of the major sector. And what is the formula for the area of the major sector? The formula is what? 360 minus what? Alpha all over 360 multiplying pi r what? Squared. Plus the area of the triangle that we can see. So plus half r squared sine alpha. All right. So this is the formula that we can use to calculate the area of what? The major segment. Now, let us look at some few things here. Let us take this triangle out. Sometimes we can be asked to find the length of the chord. So if this is A, this is O, and this is B, how can we find the length of chord AB? It's simple. Now we know from O to A to be R, O to B to be R, all right? It makes this triangle to be what? An isosceles triangle, all right? Therefore, for we to find the length of this chord, the simple approach we can use is that we divide our chord into two. So we trace our height as we can see. And anytime we trace the height is perpendicular to this horizontal. So the angle here is 90 degrees. I can put N here. And since this line bisects this chord into two equal parts, from here to here is the same as from here to here. Now, one thing you need to also know is that the angle here will also be bisected into two. That is one property about isosceles triangle. Anytime you take your height, the angle will be divided into two. The baseline will also be divided into two. So if the angle is alpha, then here will be alpha over 2, alpha over 2. So what can we do? Now, we are looking for half of it. So we can say that from triangle ONB, that is ONB. Now, we want to look for this side. And this side, when we take it, as we can see here, what can we say? O is here, N is here, B is here. This is R. Our angle here is alpha divided by what? 2. Now, we want to find NB. And NB is opposite to the angle. And we have our hypotenuse. So, opposite and hypotenuse, we are going to use our sine ratio. So, we say sine, then we break our angle. Alpha divided by 2, all right? And in question, this will be a number, all right? So alpha divided by 2 equal to opposite, which is our NB, all over what? Our hypotenuse. So opposite over hypotenuse. And we are going to have this. Then what do? We use our radius to multiply this. So our NB, all right, will be equal to our R, multiplying sine into bracket alpha divided by what? 2. Then when we use this to multiply this, we are going to get a number. All right. So what do we do next? Then we can say that our AB should be equal to the number that we'll get here. We are going to multiply it by 2, and that will give us the length of the chord. So we can say 2 multiplying our R multiplying sine alpha divided by what? 2 is going to give us what? The length of the chord. So this is how we can find the length of the chord from the circle. Now watch out for more questions on this. Thank you.